Today I'm going to talk about event-based APIs and kind of thinking beyond those REST-style APIs that we're probably already familiar with. My name is James Higginbotham. I work with a lot of organizations, particularly enterprise IT, but also software as a service. I do a lot of work helping people get their API program up and running, mature that program, and scale it. I'm a software developer by nature, so I come in and help also with API designs. So what I'm sharing with you today are some insights from some of the organizations I've been working with and some of the trends and patterns that we're seeing. So we're going to talk a little bit about some of the different styles of event and stream-based APIs that we're seeing, and then talk a little bit about what this might mean for the future of APIs as we move forward. Also, I'm based in Colorado Springs, so it's great to be just right up the road here in Denver. So I love Denver, and APIs is a great combination. Before we get started, I want to talk briefly about what we've seen so far. Many of you are probably involved with API programs that have spanned several years, maybe even over a decade, maybe decades. If they were REST, they go back to SOAP, maybe even some Corba. Anybody? Yeah, got a couple of hands raised there. So there have been API programs for a long, long time in organizations, and most recently we've seen proliferation of REST-based APIs. When we think about APIs, what we're really doing is thinking about the types of problems we're solving for our users. And that might be our customers as our users, our workforce, our partners. It may be internal system integration, things that we've heard in the last couple of talks on this track already. And it may be just utilitarian APIs. So they solve a lot of different problems for us, and sometimes we get so caught up in just moving data from a database to a front-end application that we forget that we're really solving a lot of user problems, and those problems have different contexts. So what excites me about API design the most really is that it combines software architecture, business, and product design all in one, and is really, really exciting to me because of that intersection. But unfortunately, we get bogged down and we start building a lot of CRUD-based APIs. And a lot of us think of REST APIs as CRUD, and that's not a problem using that kind of pattern. That works for a lot of people. But a lot of times what we think about with REST sometimes doesn't always fit the right situation. And we're starting to see a movement toward a lot of other types of APIs. Roy Fielding actually warned us about that in his dissertation. So what's an API talk without a Roy Fielding quote, right? But I think it is important to remind ourselves that from the perspective of REST, it was designed to solve primarily the case of the web, coarse-grained APIs. And we're seeing a lot of shifts toward other styles. So not only just request-response style APIs like we see in REST and other kinds of protocols, but request-acknowledge, where we send a request, but we know that it's going to be running for a long period of time, so those kind of fire and follow-up style APIs. We have batch-based integrations. Those of you that maybe have done EDI or other kinds of integrations, or you're dealing with file-based batch integrations with partners today, there's still a lot of businesses that do that. Are starting to move toward more batch-oriented APIs to get rid of the file-based perspective, but still be able to offer up APIs and partner integrations. Now we're starting to see this growth toward publish and subscribe and streaming style APIs that are changing the way we have to think about our API platforms and the products that we build. So what I want to do is kind of talk about some of the different styles that are out there and what kind of opportunities exist. Before I do that, for those that may not have been involved with more message-oriented middleware, message brokers, those kinds of things, just a quick review about messaging and streaming. For many, many years, we've had message brokers, and message brokers typically offered us two styles of messaging. One is point-to-point, where we have components that send messages to a broker, and one of those components receive that message. So if we send a message out, one of the components receive it. If we send another message out, maybe the other component receives it. It's not a broadcast, it's more of a point-to-point integration using the broker as the intermediary. Then we have the fan-out or pub-sub approach, where we send a message from the publisher to the broker, and it sends that to any interested subscriber, and that's where we broadcast a particular style of eventing. And we see a lot of those kinds of opportunities through a number of different vendors here on this slide. And some are cloud-based, some can be on-prem or cloud, some have been around for a while, some are a little bit newer. We started to see now this move towards streaming in things like distributed ledgers. In a distributed ledger, what we see is an append-only style set of records. We constantly append to the end, and maybe we have a time to live for those messages so that we have a retention period of 1 day, 3 days, 7 days, a month, or perhaps forever if there's not a lot of messages going across there. And every time we send a new message, then our consumers are updated to let them know. And our consumers can be smart enough that they can go back if they want to and replay messages, which is unlike message brokers that we have today. Message brokers don't usually have that built in. Normally you'd have to have something that persists each message that goes across a queue or a topic, and then have some other sort of API or out-of-band mechanism to go retrieve them. With these distributed logs, distributed ledgers, we have this idea of append only. The client manages where they left off. They can be notified of new messages and or go back and replay old messages. And that's really, really popular for managing real-time data analytics. We can receive data as it comes in and process it. And there's a number of other uses as well. So Kafka has really popularized this. Apache Pulsar is another one. We see a few others. Some are cloud, some are not. Some are open source, some are commercial. But we see these different styles of streaming helping to supplement our pub sub and our queue-based messaging. So we have all of this available at hand internally, and we use this to really build a robust architecture inside of our organization. But when we get to the API world, we continue to do a lot of request response, and that puts us in the polling category. If I want to know when something new is there, I probably have to offer some sort of endpoint, and someone continually polls and says, well, here's the last message I received. Is there anything new? Is there anything new? Is there anything new? Constantly checking against that. What we're now seeing, and the technologies have been around for a while, what we're now seeing is a shift toward thinking about our APIs, not just as request response, but as streaming and event-based APIs that allow us to extend the capabilities of what our products do. So rather than having to go in and make a change to the code base for our existing application, we instead emit an event and allow anyone to come along and then react to that and execute some sort of logic or some sort of special integration. And rather than just using things like message brokers and distributed logs, we can instead use HTTP. And we're seeing a growth of this through a number of different styles. So I'm going to quickly walk you through some of the different styles that are available, that are out there, and what people are seeing. GraphQL is one of them, more recent entry, and they have an opportunity for subscriptions. And they allow us to subscribe, let's say, for messages in a particular room, and we'll just continue to receive those elements as they come back. We'll get those responses. So as a new message comes up, we'll get notified of it. So this is a really popular way to create more experience-oriented APIs with events or streams that are coming out. gRPC is becoming more popular for service-to-service communication. It uses HTTP2. HTTP2 allows us for bidirectional communication. So now we can define an IDL for a particular RPC endpoint, service endpoint, and we can either stream from the client to the server, or the server to the client, or both. So we actually have a little bit more flexibility and a lot more options there than maybe we don't have on other protocols. Server-sent events is a little bit more REST-like. It just uses standard HTTP. It does use a specific content type. We can just simply have these different channels here, these event channels, and then data. The data can be any kind of text, so it can be plain text, it can be JSON-based. We can do multi-line, we can do single line, we can have channels, we can not have channels. It's pretty easy, and it's actually really approachable as well. There's a header supported in there called last event ID, allowing systems that go offline to be able to play catch-up with anything they haven't seen while they've been offline. So it's really approachable, really nice. SSE has not caught on because a lot of browsers don't support it, but it's a really, really nice approach for server-to-server communication for certain, and for some browsers, if that makes sense. We're also seeing things like Websockets. So from Websockets, a lot of people are familiar with this. This is the one that's most cross-platform, works with a lot of different browsers. The challenge that we see in there is that you need to define a sub-protocol. So once we say that we're going to use WebSockets, we got to define the protocol. SSE says, here's what your format is. It's text-based. Blank line separates each of our messages, pretty straightforward. WebSockets is more flexible, but also a little bit more of a learning curve for anyone consuming that. We have to not only be able to upgrade our connection to WebSockets, but we have to know what protocol is being used and then implement that particular sub-protocol. IANA has a list of these. I'll share these slides out so that you'll have the links for these resources. IANA has a list of recognized sub-protocols. So you can pick from one of these or many of these and use WebSockets or invent your own if you want, but sometimes it's better just to kind of go with things that are standardized. And then we have things like webhooks. Webhooks have been around for quite a while. Many of us are familiar with them. For those that aren't, it allows our servers to make HTTP post calls to some registered URL, which means if we have two systems talking to one another, and we know that the network between them is accessible. In other words, we're not registering for a webhook callback that's behind a firewall and wouldn't be accessible for the other vendor to make the call from. Then we're good. We can receive an HTTP call, and we can even use all of the infrastructure we have, load balancers, things like Nginx or HA proxy or other tools to do reverse proxying into clusters of these things to receive these callbacks. So we can scale the receiver much better than we can on the client side of some of these other protocols. So this gives us a lot of flexibility, but not always the right fit if we're doing web and mobile applications since we can't expose an endpoint. For those of you that are interested in webhooks or doing them today, I don't know if you've seen resthooks.org. That's something that was put together by our friends at Zapier. Zapier has basically had to integrate, as we heard from some of the previous talks, integrate with a lot of different public APIs and callbacks. And they found that there were some patterns that they had discovered along the way for managing subscriptions and other things. They built that into a site that just simply lays out some patterns, practices for securing and managing subscriptions in a programmatic fashion rather than requiring some sort of like mechanized script to pretend like they're a human going into a dashboard to register the URL for your callback like some APIs might require you to do. So they've just kind of captured that in a really nice website. So with all of that, we have all these different styles. What does that really mean to us? Why do we care about APIs? Well, there's three core opportunities that this presents to us. The first thing is innovation. GitHub was probably the most popular and the most prominently used webhook for quite some time other than perhaps Twilio. GitHub, in essence, turned a script-based hook for when we push commits into Git and made that go over HTTP. By doing something as simple as that, they created an entire CI/CD marketplace of SaaS solutions. If you think about our continuous integration and deployment pipeline scripts we've had to build, prior to having this kind of webhook capability, we would actually have to write all of that code ourselves, probably inside on some of our own servers, our own hosted repositories. Whenever there was a push, we would run all of our code, quality scripts and everything else, and we do that all ourselves. We can now outsource that entire CI/CD pipeline to some third party through the virtue of creating webhooks. So think about what you're doing today. What is it that's happening inside your product, inside your enterprise, inside some sort of integration layer that you're building that might be of interest to someone else, and what kind of events could you expose through webhooks or through some other protocol or style that would change the way the people that use your software look at your software? That's what GitHub did for us. And a lot of other businesses do that as well. But I have to give a shout out to them because they really have transformed the way we build software today. Opportunity number two, it's allowing us collaboration. We have a lot of these jobs that we have to do every day. Every one of us has to get things done, and we're also probably building software for those same people inside our workforce or outside our organization that integrate with us, our partners, our customers, whatnot. They have jobs to be done. And our APIs are there to meet them. And we build different APIs to support that. Well, what we have now is this growth of messaging platforms. These collaboration platforms that are now bringing us to these environments and allowing us to be better at communication with each other, get our jobs done faster, collaborate in different ways. When we think about these platforms, what they're really doing by virtue of supporting different kinds of API integrations is they're allowing the users to move from going to an application to get something done to the applications coming to the users. Because now we have users inside these messaging platforms, and they're getting things like workflow requests, approval requests, other things happening inside the platform. So now we don't have to open up and have 20 different tabs open with all the apps we use every day. We sit in our messaging platform and allow things come to us. So the processes automate until they can't automate anymore. And then they go reach out to someone, we answer, and then we move on. It's a much different way of doing things. And so we use APIs with things like hypermedia links and other kinds of opportunities to make these message platforms aware of what kinds of things can be done, what actions we want to take, how to visualize it, and so on. And then we can fire off events once the user has interacted with them in that messaging platform, which then just simply feeds that cycle and just continues to produce better automations, better integrations in an amazing way. We're also seeing in these messaging platforms, particularly like Cisco WebEx Teams, as well as Slack, the ability to not only just webhooks and WebSocket-based streams, but actually bidirectional webhooks. So now systems aren't just firing webhooks off, they're actually becoming subscribers. And what that means is we can have a messaging app which dispatches out a webhook over to some sort of subscriber on the other side, which might be a workflow engine like I showed in the last slide, which has some sort of message that the workflow engine turns into some sort of human interaction, which then the event of that gets redispatched back to the messaging app, which turns into a message that shows up into the stream. So not only can we listen for those events in which we need to ask someone what to do, but we can also then receive the result of that and post that as a message in one or more of our team rooms or whatever to announce that decision has been made. So we're now seeing this idea of bidirectional webhooks, which is really exciting. So now we can have systems kind of talking back and forth to each other and automating even in a more deep fashion. The third thing we're seeing, and this is more on the stream side, is operationalizing data. When we think about data today in what we used to do, we have lots of different databases all throughout, and we have really smart people that are really good at building ETL processes to move our data around, transform it, do whatever we need to with it. So we had a lot of ETL processes. With the amount of data that we're generating now, we're actually seeing a bit of a shift. The shift is now not from the idea of having lots of databases that are ETLing to one another. We're instead streaming a lot of data out into these data lakes. These data lakes have structured data, semi-structured data, or unstructured data, and they're all going in there. And then we have really smart people that are doing machine learning off of them, different kinds of business analytics, driving decision systems. So what we have now are these streaming systems that are streaming into data lakes. We then use tools like Apache Spark or other kinds of tools to do big, large queries over that data. We transform that data to what we need it to be, not what someone else tells us it should be. We get it in the format we need it to be in. And then we analyze that and either feed it back into the data lake or feed it into a data warehouse or a transactional system or whatever else we need. So our data management processes are changing by virtue of the way that we're streaming. So what I like to say is we're moving from ETL to more of like an ELQT. We extract and load through streaming into those data lakes, and then we query and transform, and then we execute whatever data analysis that we have. So this is really changing the way that we're interacting with data, and that's affecting our APIs directly now. So what do we do about this? Well, there's a few things that we can do. First off is to recognize that while API programs in most organizations start fairly simple, we have a front-end web, mobile apps, we have maybe REST APIs, GraphQL APIs, we have databases. Really what we need to be doing is thinking more about capabilities. What are the things that the users need to do? What are those jobs to be done? And then how are our APIs supporting that? And which API style or styles will best support those capabilities? A lot of those request response will work great. Sometimes we might need specific kinds of events to be able to support the types of interactions that we need. As we start thinking about that, our API that seemed pretty simple that talked to a database now really starts to break down to capabilities and operations. And those operations are things like queries, commands, and events. So those of you that are familiar with CQRS, yeah, I stole it from CQRS. But I think it's important to think about our APIs, whether you're using the CQRS pattern or not, think about things as queries, commands, and events. And when we think about it that way, now we start to think about what kind of capabilities do we need to deliver, what kind of operations do we need, or do we need to support to deliver those capabilities? And then from there, what kind of events as output might be useful for others to integrate with us as a result, or to trigger particular types of outcomes for our users. So our enterprise journey is changing a lot. We have our enterprise with our APIs, and we have our marketplace with all the people that use them. And then we've started to do things like break those capabilities or operations into microservices. So now we have these microservices, or monoliths, or modular monoliths, or however you want to look at them. I'm open to any of those, that realize these and help compose these APIs. So we have all these capabilities and operations that roll up into these APIs that help people get things done. And now we have these streams that are operationalizing our data, making us a lot smarter about what we do in our business or how our users can benefit from us. So we're seeing this evolution of the enterprise platform from what used to be just APIs and databases to much, much more than that. We have different API styles to choose from, and we might need more than one. This isn't a versus, this is an and kind of situation. So if you're thinking about writing an article that's GraphQL versus REST or something like that, please stop now and don't do it. And if you've done it, we'll forgive you, blanket, forgiveness, but let's move on from the verses. I lived that with, thank you, I lived that with Vim and Emacs. And Emacs is right choice anyway, so who cares? Divisive. I've lived that with Java versus .NET. I've lived that, and I tell you, after a number of years of dealing with that, not one good came from it. So instead, let's think about how can we, as API producers or API consumers that are going to be working with those producers, build APIs that solve end-user problems, that offer those solutions using one or more styles that are appropriate for that target audience for that solution. And let's look for the events that we're not externalizing today that would make people have an experience like we've had with GitHub's webhooks or Twilio's webhooks or anybody else that does events. Think about all the APIs you've worked with where you've had to work through all kinds of hairy problems purely because they didn't have an event that would inform you when something changed. Yeah, I see the head nods. You've felt that pain. So how can we help the API consumers consume our API in different styles and in different ways that meets what they need to get those things done for the users? In addition, we have to think about the data management and data processing aspect of our APIs. Our APIs are going to be nothing without the data, most likely, unless they're utilitarian APIs. They take input and they do something with it and they spit it right back out. So we also have to think about how we're going to work with those teams that are responsible for data management, data governance inside of organizations if we're a larger one. For a smaller organization, mid-sized organization, we don't have a formal data governance, data management team. We, as API owners, probably in some ways, directly or indirectly, own that data. And we have to think about what that kind of style of interaction means to our end users that want to action on the things that we've been managing down below. All of that drives us to the idea that our decisions both impact the API styles and protocols up above that we use to externalize the APIs, as well as the underlying capabilities and operations that we're going to be turning into APIs that help people get things done. So what we're seeing and what I'm seeing in a lot of organizations is this idea of APIs delivering capabilities through commands and queries, REST, GraphQL, gRPC, some combination. Events and streaming allow us to extend the software beyond what it was originally designed to do without that core API platform having to be aware of all of those consumers. It just simply emits events and says that my job is done and you have fun with whatever you want to do with that event or that stream of data. We use discovery through Open API and the Async API specification, which I'll talk about more in a bit. And we use things like functions as a service and iPaaS to build that integration glue. Functions as a service, I know was mentioned earlier. There's a lot of opportunity here that's untapped. And imagine if we have events that are firing off, that glue code doesn't have to be a 24/7, 365 running process to listen for that event, but rather can be a function as a service that's just invoked whenever that event kicks off. Really powerful opportunities start to emerge. Stories abound with either inside your enterprise or with your customers of your product when you can start empowering them to act upon those events in a very, very simple way. So I mentioned Async API. For those of you that are familiar with Open API but not Async API, Async API is not managed by the Linux Foundation, but it is mimicking a lot of its design ideas for capturing event and message-based structures in a format similar to the way Open API does. So it's a very easy transition. If you start doing eventing, one of the first things you'll run into, and a lot of organizations are not doing it currently, is capturing, defining, and applying different styles and style guides and governance even for some of them to the way they define their event and message structures. And so Async API is a really nice way to get started. There's a version 2 and a release candidate stage, so now's a great time to jump in on version 2. There's going to be lots of tooling emerging with that, and it's going to be very, very similar to the Open API space. So if you haven't checked it out, please do. I work with the team part-time, trying to help them steward this specification forward. It's a really great initiative and has a lot of big names behind it, so it's going to be around for a while. So when we think about Async API, one of the things we can think about, I deal with a lot of Avro as a result of dealing with Kafka inside of organizations. We might define particular schemas, and we can, so we have an Avro definition on the right and an Async API definition on the left, and we combine those things together so that we can make our events discoverable across whatever protocols they're available for, and then go from there. The other thing we have to think about, and one thing that I've shared, is this microservice design canvas. Whether you're doing microservices or if you're just building coarse-grained services or APIs, this is a way that really lets you reason about what you're designing before you get into all the specifics. This is based on some work that Matt McClarty did. It was based upon the lean canvas idea, which was based upon the business model canvas by Osterwalder. So there's this kind of idea that's growing about how do we reason about things at a high level and help communicate in high fidelity with our Open API specs, but reason about them at a higher level. This is a great way to do it, and we break things into queries, commands, events published, and events subscribed. So if you're trying to figure out how do I start thinking about events, start trying to plot something you already have up here or the next design session you have for an API. Start to fill this out with your operations and your queries, and then start thinking about what kind of events might be interesting. Along with that canvas are these little cards. If anybody's ever done C or C cards, I kind of modeled it after that idea. So if you want to just trim it down to something where you can draw lines or paste them up on a whiteboard and draw lines between them and whatnot, you can do that as well. All right, so with all that said, let's put on our futuristic goggles and think about where are we heading with this. Well, just to kind of call out GitHub one more time, I don't know how many people have seen GitHub Actions, but we have this idea of GitHub now hosting the management of our CI/CD pipeline or any kind of post-processing when we do a Git push to a repository. Instead of having to register a webhook and do the work ourselves, we can actually define these different steps and they'll run them inside their own infrastructure. So they're offering hosted serverless behavior based on the events of a particular repository. So we're starting to see this growth idea of events happening and the behavior or the response to those events not necessarily being within your own control. They exist outside of your control. So I'd imagine we're going toward a future with all of these events where the integration logic is not always going to be necessarily hosted by you. It may exist somewhere else. It could be a function as a service inside of a cloud vendor or something else. Whatever the case is, we're starting to see this growth such that now these events are becoming a lot more powerful. And those of you that have been around for a while, like myself, might remember Visual Basic. And Visual Basic, during those client-server days, you would point it, you would build the UI with some sort of UI building tool, and then you would, on a specific event, drop into the function and write the code necessary to react to a particular piece of behavior. It could be user-driven or back-end driven. We had things like Power Builder, Delphi, those kinds of tools as well. Yeah, I see those looks of glean and that glint of, I wish things were that simple. Then we had, so we had that in the 90s, and then in the 2000s we had SOA and SOAP, and we tried that again, and we used things like BPEL to wire up services together, and it kind of worked and kind of didn't. But every generation of technology, we see this desire to try to reduce the amount of code we have to write. And as was mentioned in one of the previous talks in this track, we do not have the number of developers necessary to build software. So why do we want to build another login screen or another view screen onto something that probably follows some very similar UI patterns? So I think what we're going to see is a kind of another cycle of this, but rather than being desktop apps or SOA services with WSDL files behind them, we're probably going to see them with more of like an open API spec, async spec that's driving these tools. Not because we don't value the craft that many of us in this room are involved with development, but that our time is important and the number of resources that we have within an organization are finite, that those of us that are really good at building APIs or composing services should be doing that. And the people that are good at building front-end UIs that are custom and that are going to live a long time, that are going to last for years or longer, should be really good at that. But there's that piece in that middle where we might need something for a 2-week marketing effort. Do we want to pull our developers that are really good at those two things to build an app that's going to get thrown away in 2 weeks? Probably not. And I think these ephemeral apps, this idea of it's going to start to grow. We're seeing things in the IoT space like Node-RED. We're seeing IFT and Zapier already out there that are cloud-hosted automation and integration solutions. Anyone used Apache Airflow? Well, Apache Airflow is pretty popular for like data analytics. Because it's really has a really good support for Python. A lot of data engineering teams use it to build the data cleansing and data analytics workflows. But it's just based on DAGs that allow us to define parallel and sequential steps and allow us to stitch things together. And then we have an entire language built up called Ballerina that came from the WSO2 camp, that is just a language designed to be good for integration, that it's good for doing parallel tasks and integrating different services, and it's very expressive. So all of that to say that we're on this path toward an idea of having developers that are more like a business level developers that would be writing in traditional Visual Basic for applications, kind of VBA macros in Excel and others, to be able to stitch these things together to get the data the way they need it, and maybe to build an application whose data sits behind an API. So we can throw away the application itself, but the data still lives and the capability still lives through APIs. So I think we're headed down a path where we're going to have to welcome this idea that not every line of code needs to be crafted the way we'd want to craft it, because the urgency or the longevity of that code may change. The requirements may change. And we are going to be entering this world where integration, which is very popular in the enterprise space, B2B space, the ERP world, all of these different solutions that exist out there that we've been doing for years, it's just going to grow. Because if we have 10,000 public APIs or 14,000 publicly available APIs, we have hundreds of thousands of private APIs. And there is absolutely no way that inside of an enterprise that has hundreds to thousands to tens of thousands of endpoints are we going to want to handcraft all that integration code. So we're going to need tools and environments and languages to be able to support that. So I think that's where we're headed. I would be on the lookout for it, and also look for ways that today you can prepare for that by offering up and building in events and streams into your API offerings, in addition to your request response APIs with GraphQL and gRPC and REST, that will prepare you for this so you can empower your business and your customers to do really, really powerful things that they couldn't do before. I think that might be my time. That's it for now. I think we might have time for maybe one question, and then we have our break. Anybody have a question or anything? Stunned silence. All right, perfect. Oh yeah, go ahead.
Just a quick one. What was the second tool you mentioned after Airflow?
This one down here in the bottom corner is Ballerina. Yeah, Ballerina Lang is out there. Really, really interesting. Take a look at that. All right. Yeah.
Weird question, but do you think there's like a really good way of communicating like the API needs and the need to expand that to clients if you're not necessarily an in-house team and to kind of talk to maybe a business audience? And are there like tools, I guess, that are being enabled by this sort of like API integration landscape?
So it's interesting you mentioned that. I did a recent talk about that. There's a markup language called ALPS, ALPS, and that allows us to reason about the capabilities and the data without talking about all of the HTTP protocol details. Beyond that, I tend to just think about boxes and arrows and flows. And then as the API providing team, your responsibility is to turn that into the endpoints necessary to realize that. That's the best way to, and that's why I like the jobs to be done approach, because it doesn't think about the user story from as a developer, as a end user, as an admin, whatnot. It thinks more about the triggering event. So when something occurs, I want to do this so I can have this outcome. And so they're called job stories, and they're based on the jobs to be done framework. And sometimes what you can do is you can have those discussions in a loose format, turn them into those job stories, which kind of give you a structure, which then become the realization of those capabilities, operations, commands, queries, and events that you end up dealing with. But I don't, without going into something that's very vertical specific, I don't know of any kind of general approach, but that would be my approach. Yeah. All right. Thank you very much.